Okay, so this last problem is a volume problem. So just a reminder, we've been asked to find the volume generated when the curve y equals 1 on the square root of x is rotated about the x-axis between x equals 2 and x equals 4. So now, it hasn't asked us to sketch this, but we're going to sketch it anyway. The graph y equals 1 on the square root of x will look something like this. It's just taking a graph of 1 on x and square rooting the x value to make it smaller. And we've been asked to find between x equals 2 and x equals 4. So let's say that x equals 2 is here, x equals 4 is this bit here. So we're taking this section and rotating it around the x-axis. So a reminder of the formula for volume is that volume equals pi times the integral between a and b of y squared dx. So for us in this question here, the volume is going to be equal to pi lots of the integral between 2 and 4. Now, y in this expression is 1 on the square root of x. Therefore, y squared is 1 on root x times 1 on root x, which is just 1 on x. So 1 on x dx. From here, we can now integrate this. So with pi lots of. We integrate 1 on x, we end up with ln x between 4 and 2. And then we get pi. Now, if we simplify this, we end up with ln 4 minus ln 2, which is the same as pi ln 2. And again, if you've watched the previous two examples, this is again using log law. If you've got ln of a minus ln of b, that is the same as ln of a over b. So ln of 4 over 2. And so there's our final answer, which is pi lot of ln 2 and its volume. So we'll put a units cubed in there as well. Okay. And that's how we find the volume of revolution when y equals 1 on the square root of x is rotated around the x-axis.